So here's my slide on how to solve rationals. I do want to put in this major caveat up here, which is there are many different ways to solve rational equations. I do my best to use one method in order for consistency. The method that I've chosen tends to be the most successful for the majority of my students. That being said, if you look at Khan Academy, if you're looking at Florida Virtual School, or any of your other online resources, you might find different methods. Choose the one that works best for you. This is my method, and you can find my method right here. So no matter which method you're doing, the very first thing you need to do is to find your restrictions. You're going to check those at the very end. This middle part is really how I do my method. This is where the difference is going to be. So what I do is I make sure that we always complete the shown operation and simplify each side of the equation down to one fraction. So oftentimes that operation is going to be addition or subtraction. So that is what we're simplifying there. Once we have one fraction, a rational expression, on both sides of the equal sign, we're ready to cross multiply. And we just looked at that on the other slide. So in order to solve, all parts of the equation must be on the same level. And what do I mean by that? We need everything on the level of the numerator, which is why we multiply that denominator over to the other fraction. So that's that cross multiplication. And I do give the reminder to make sure that you are actually multiplying at this step. Once you've done your cross multiplication, you're ready to solve for x. You do need some reminders down here. The first one is just really good math, and it's a reminder that when you get to the solving stage, when you've done all your simplifying, you found your restriction, you've done the addition, you've done cross multiplication, you're ready to solve. If you get to the stage and you see that you have a quadratic or something of a higher degree, you have to actually set it equal to 0 and factor. So what I mean by that is if you find out that you have an x squared or an x cubed or an x to the fourth, then you're going to set the whole thing equal to 0, and then you're going to factor. That is a major step. If you don't do that, you will end up with the incorrect answer. And then last but most definitely not least is this bullet point down here, which is if one of your solutions is a restriction. So the very first thing you did was find your restrictions. If one of your solutions is that restriction, it's known as an extraneous solution. So say that at the very beginning you found out that x couldn't equal 3 and x cannot equal -1. Then, when you found your answers at the very end, you had x equals 4 and x equals -1. If this is the case, you would say, hey, I know that x cannot equal -1. It says x equals -1, but that is one of the very few answers that I'm not allowed to have. So you'd cancel that one off and say, nope, that's not possible. So let's go ahead and start trying. It might be useful for you to always kind of write those steps down to the side so that you can remember what you're doing each step of the way. I do each of my steps in a different color so that I can remember what is my goal here, what is actually my process here. So the first thing I want to look at is my restrictions. Well, we know that our restrictions come from variables in the denominator. So once again, our restrictions come from variables in the denominator that would cause the entire denominator to equal 0. So I look and I have 4, 3, and I know that this is actually over 1. Well, 4, that's not a variable, so there can't be a restriction there. 3, that's not a variable, so there can't be a restriction there. 1, once again, that's not a variable, so there can't be a restriction there. So for this problem, I would actually say no restrictions because there are no variables in the denominator. So now we're ready to move on to step 2, which is adding and subtracting. So I need to actually, on this side, I have x minus 4 over 4 and x over 3. That's two different fractions. I need to actually simplify it down to where it's only one fraction. So that's my goal here. I know that in order to add, they need to have the same denominator. Well, right now I have 4 and 3. 4 and 3 don't have anything in common, so they're going to be multiplied by each other. And this is that step of multiplying by a well-chosen 1 in order to make sure we have a common denominator. I can now look 12 and 12, that is a common denominator, so I can go ahead and add my numerators. 3x plus 4x is 7. And now I'm done with my adding and subtracting. Before we move on, I want to call out this idea right here, the 12 over 12. There's going to be some of you who right now want to say cancel 12 over 12. But as a reminder, you can only cancel factors, and 12 is a term. I know that because it's separated from 7x by a subtraction symbol, and factors are separated by multiplication. This is not multiplication. 12 is not a factor. I cannot cancel. So we go back. I told you I'm going to use different colors. Step 1 was red. I add and subtract in this greenish color. Now I'm ready to cross multiply. So my cross multiplying, remember, just means taking whatever denominators you have up to the other side. And I did say, go ahead and actually multiply. So that's what I mean here. I did go ahead and actually multiply. Now that I've done that, I'm actually ready to solve. Because this is just a linear or normal, it's not squared, cubed, anything like that, we can use those skills of solving that we've been using for years, that's SADMEP. So I'm going to start with my addition and my subtraction. Now I'm ready to go into my division. And I'm done. My very last step would be go and check my restrictions, but because I didn't have any, I know that I'm okay and we can go on. So that was adding and subtracting, or sorry, solving a rational using addition and subtraction of rational expressions. Let's try it again. Step 1, restrictions. So I'm looking at the denominators and saying which denominators have a variable. This one has a variable. This is also the same thing. So I can come over here and say x plus 2 cannot equal 0. Therefore, x cannot equal negative 2. So I found my restriction. Once again, this one didn't matter because there wasn't a variable in the denominator. Now I'm in my addition and subtraction stage. When we add and subtract, we know that we want common denominators. You can make x have the same denominator as x plus 2 over here, but instead what I see is that x plus 2, these already have the same denominator, so I'm going to move this entire term to the other side. I did that once again so that I already had a common denominator and I was able to go ahead and just add and subtract. This gives me x, because that's still left on the other side, equals, I can remember make this addition, this subtraction, so 5x minus x is 4x. That was way simpler because I was able to add and subtract rationals that had the same denominator. I didn't have to do any of that multiplying by a well-chosen 1. Now I'm ready to cross multiply. So the only denominator I have is going to go up to the other side. I need to actually multiply here. So I went ahead and multiplied it out. I'm now ready to move into the solving phase. In the solving phase, I immediately notice that I have this squared. So that is that reminder we talked about, that if your degree is 2 or higher, you actually need to move everything to one side and then factor to solve. So moving everything to one side, I'm going to move my 4x and my 8 over. So that gives me x squared. 2x minus 4x gives me negative 2x. The negative 8 didn't go in with anything. We're good to go. Bring this over. Here I need to factor it. Well, this factors to x minus 4, x plus 2. I know that because negative 4 plus 2 gives me negative 2. Negative 4 times 2 gives me negative 8. I can do that because my leading coefficient is 1. I can set each of my factors equal to 0 and go ahead and solve. Now these are my two possible solutions. Many students want to end right there, but the reminder is we did this very first step to check for our restrictions. We know that x cannot equal -2, so I just say, is that here? X cannot equal -2, x equals 4, we're fine. X cannot equal -2, x equals -2. X cannot equal -2, x equals -2, we choose the restriction. The restriction wins, and so we say, hey, that's not actually our answer. This is our answer. On occasion, both answers will be correct. You have to go back and double check with your restriction. This is saying the few answers that your x cannot be. So when I saw that, I said, nope. All right, I think I got two more examples for you guys. We're going to keep seeing the different levels that we have. I liked the last example. I'm sorry about my screen there. I liked the last example because A, it had a restriction and that caused an extraneous solution. Also, we had to factor in order to solve. So there are multiple different parts here that were really cool. So the factoring to solve was really important. Once again, having a restriction, and then furthermore, that restriction causing an extraneous solution. This one has one other really cool thing that I want to show you guys. So first off, we're going to start immediately with those restrictions. In order to do so, we know we have to have our denominators factored. I know this is x plus 2, x plus 3, because 2 plus 3 gives me 5. 2 times 3 gives me 6. Once again, this works because my leading coefficient is 1. And I'm going to say, what factors do I have in my denominators? Well, I have x plus 2 and x plus 2. So I say x plus 2 cannot equal 0. X cannot equal -2. I also have x plus 3 and x plus 3, so I say x plus 3 cannot equal 0, so x cannot equal -3. This is what I have to go back and double check. I so apologize for that. Please stay with me. Now I'm in the adding and subtracting stage. So in this adding and subtracting stage, we know that in order to add, we need a common denominator. Well, I see they both have x plus 2, but this one needs x plus 3. So I don't really have enough room to do that there, so I'm going to go ahead and write it further down. My first fraction, it's not changing because it has both the factors. My second fraction, we said it needed that x plus 3, so it's going to be multiplied by x plus 3 on the top and bottom. As a reminder, that is that well-chosen 1. At this stage, we know we have to actually multiply in the numerator, so I have a binomial times a binomial, so I'm going to FOIL or distribute each term to each term. So once again, my 3 didn't change. This one did become, however, x times x is x squared. X times -1 is -x. 3 times x is 3x, and 3 times -1 is -3. Do not forget that this is actually set equal to 7 over x plus 3. I'm going to go ahead, now that they have the same denominator, I can go ahead and combine my like terms. X squared is by itself. -x plus 3x gives me 2x. And then I have 3 minus 3, well that's 0, so I don't actually need to write that. So now I've gone ahead and done my adding, and I'm ready to do that cross multiplication stage. However, I want to show you something with this one. If you remember back on one of the very first slides, we said that if we had 2 over 5 equals x over 5, 2 must equal x. Because the denominators were the same, the numerators must be the same. Well, if we look at this one, we can actually see that really close, our denominators are almost exactly the same. They both have an x plus 3. This one just has an extra x plus 2. So instead of cross multiplying, I can actually multiply this one by x plus 2 on top and bottom. That gives me x squared I'm going to run out of room over here. I'm going to bring it up here. That's going to give me x squared plus 2x over x plus 2, x plus 3 equals, I'm going to distribute that 7, so I get 7x plus 14 over x plus 2, x plus 3. So the reason why that was really cool is that now, because my denominators are the same, I can go ahead and just set my numerators equal to each other. I'm now ready to go ahead and move into that solving stage. So in that solving stage, once again, I see that it's a quadratic, so I need to bring everything to one side. I can go ahead and factor that. Solve it. And then last but not least, double check those restrictions. So my restrictions are -2 and -3. I see that I have a -2 down here, so I'm going to say that can't be my answer. So x equals 7 must be my answer. So before we move on, I do want to talk about what I did here one more time. I knew that if I could make my denominators equal to each other, I could go ahead and just set my numerators equal. So I did the same thing I would do when I was trying to make a common denominator in order to add. I said, what do they already have in common? They already have an x plus 3 in common. So what do they have in uncommon? This x plus 2. So I gave it to this side as a well-chosen one. When I did that and came up here, I then had two fractions on either side of an equal sign that had the same denominator. When they have the same denominator, you can go ahead and set those numerators equal to each other, which is what I did in this step. Right. I'm going to do one more example for you. Very first thing we're going to do is look at those denominators to look for our factors and our restrictions. I see that I have x plus 2 and x plus 2. So I say x plus 2 can't equal 0, x cannot equal -2. And so I have x minus 2, x minus 2. So I say x minus 2 can't equal 0. So therefore x cannot equal +2. Those are going to be my restrictions. Those are what I'm going to check at the very end of my problem. I now can go ahead and say I know that I need to add on this side. I'm not going to move anything over here because neither of these have a perfectly common denominator over here. So I'm just going to work on these. As I look, x plus 2, x minus 2, they do not have anything in common. So both of them are going to need to be multiplied by a well-chosen one in order to get a common denominator. I'm going to give the x minus 2, I'm going to give the x minus 2 to the first one. That means I need to give the x plus 2 to the second one. Don't forget to distribute, that is extremely important. Well, this one was really, really cool because when I got ready for my addition and I gave these a common denominator, notice that it became x minus 2, x plus 2, x minus 2, x plus 2. That was actually the common denominator on the other side. And because it's the common denominator of all of it, I'm actually ready to go into that solving stage, which is just setting the numerators equal to each other. So once again, because they had a common denominator all the way across, I can just deal with my numerator. So actually, as you guys look at other methods on solving rational equations, that is one of the most common methods, is to multiply each fraction by a well-chosen one in order to make the denominators disappear because they will all have the same denominator. So this is a method that you'll see in other ones. You'll just see how it showed up in our problem here. Now we're ready to go ahead and keep solving. and we end up with x equals 3. Don't forget we need to go and double check, but that was not one of my restrictions, so I am good to go. That is my final answer. So there you have it, solving rational equations. There is a lot of work, but notice that I always separate my steps to figure out what I am doing. I started out with my restrictions, then I did the addition. This was the getting set up to solve. Typically, it is the cross multiplying. In this problem, it just happened to be just taking the numerators because all of our denominators are common, and then actually solving. Do not forget that your very, very last step is always to go back and double check those restrictions.